This video is going to cover really the basics of physics, starting with the great question of what is physics? Well, that is the study of matter, energy, and the interactions between them. Now, hopefully you guys have a pretty easy sense of what energy is, right? If you turn on the lights, if you charge your phone, you're utilizing energy in some capacity there. Now, what I really want to make sure we have a solid definition of is matter. So matter is anything that has mass and takes up space. Now, obviously, all of you are made out of matter, right? You have mass, you physically take up space. On a grand scale, we can easily say that our building that we exist in, the building of Reardon, has mass and takes up space. But this also goes really, really, really tiny as well. So within a single atom of hydrogen, there is a nucleus that has a proton and a neutron, and in the outer cloud is an electron. All those little individual particles, even though they're so small you can never actually see an individual one, have mass and take up space. So we've got that definition down. Now our big goal is to actually look at how matter and energy interact in our daily lives. The basis of all life is pretty much physics in nature. You can bring everything down to physics, whether it is a biological principle or a chemistry principle. It all comes down to physics because it looks at the very basic interaction of matter and energy. So our goal as a scientist is to ask fundamental questions and answer them through observations or conducting an experiment. The questions that you might have are going to be, really different from person to person. For example, I have a lot of students come through and ask, why is the sky blue? That's a fundamental question. Why is the sky blue? That one is a little hard to answer through observations. You really need to be doing experimenting at almost an astronomy level, if you will. There are other questions, though, that can easily be answered just through observations. For example, you could wonder if there are more earthquakes during the spring-summer months or the fall-winter months. That's just a quick observation of, how many earthquakes are there during that time? You don't need to really do an experiment for that one. Now, observations are actually a very powerful tool that oftentimes are kind of overlooked and not really considered super important. But I'm going to take pro athletes, for example. Pro athletes tend to record themselves while they're practicing or during a game or just in conditioning. And they rewatch those tapes to see, hey, how am I doing? Where do I need to improve? Am I putting my foot down at the right spot? Do I need to shift my weight somehow? Whatever is going to make them better. They literally watch themselves to improve themselves. Now in science, we have two types of observations. We have quantitative observations, quantitative's base word being quantity really, and then qualitative observations being a base word of quality. Now I'm going to put some definitions and talk them through. Again, you can see now our two types of observations. Quantitative has to do with numbers. So you could say, I'm sitting in my classroom and I count 14 other boys with purple sweatshirts on. Great, that is a quantitative observation. Qualitative has to do more with your senses. That's what I meant by quality. So what can you see? Can you see that everyone in the room is wearing khaki pants? That's qualitative. What can you hear? If it's loud, if it's high-pitched, if it sounds like something's dying, that's all kind of qualitative observations. What does it feel like to touch it? If it's safe to touch, or if it's reasonable, I guess, to touch something, what does it feel like? Is it hard? Is it rocky? Is it smooth? Is it really rough? Now, smell, in physics, you might not have that many qualitative observations to do with smell. If you are sniffing an unknown substance, you might not want to smell, just straight up smell it. That seems like a bad idea, right? But you could have smell as one of your observations. Now, this final one, taste. You really have to be in the right experiment to be tasting something, right? You don't have many instances where tasting something is going to do you well. So always take that one with a grain of salt. My go-to suggestion at all time is just don't do that, right? I won't give you an experiment that has to do with taste unless you're in my chemistry class. So I'm going to kind of show you my own practicing of observations. Now, I just took this screenshot of the Google artwork for today. Now, looking at it, there are a lot of observations that can be made, both quantitative-wise and qualitative-wise, at least in terms of sight. Now, this was a little video, so there could be more, but I just took a single screenshot. Now, quantitatively, I've already written down some of mine, but if you look, I'm sure you can figure out some things to do with numbers. You actually have to count. But right off the bat, I see 8 slices of jalapeno peppers, I see 3 pots hanging up, and then I see 2 cheese graters on the side. So all of those have numbers. That's what makes them quantitative. Now, in terms of qualitative observations, I can see that most of the picture is drawn in yellow, and that's with me ignoring the background. So take out the background, most of the objects are yellow. I can also see that this man's nose is touching the bowl or the plate, which is kind of gross, and that he has very, very small eyes. I can also recognize that the word Google is written in blue. So that's just kind of some examples. I wrote them down under here. I identified them as quantitative versus qualitative. Now, there are plenty more observations to make here. There are just a ton going on, but for right now, this gives you just a quick example of what that looks like. During class, we're going to have time to practice this, so just make sure that you fully understand the difference between what a quantitative observation is and what a qualitative observation is.